Good morning, class. This is Mr. Walker here, coming to you with our lesson about arcs and chords. So, we are getting into the nitty gritty for our circles unit. So, now we're going to learn about some new parts to our circle. Let's talk about it. So, at the beginning, we're going to talk about something that's new but also a little bit familiar. We have a chord. A chord is a segment whose endpoints are on a circle. So when we talk about on the circle, that's talking about the actual curved part. Now, we've actually dealt with a line like this, that is a diameter. A diameter is a type of chord, but not every chord is a diameter. Remember, diameters go through the center. Chords don't necessarily have to go through the center, they just have to have their endpoints on the circle. All right, next thing we got to talk about is an arc. Now, we talked about arcs in terms of marks in the past, but an arc is actually a section of the circumference of a circle when we're in this subject. So that means if we're talking about the circumference, that's the whole outer edge of the circle. An arc is a smaller part of that whole edge. Finally, we got the central angle here. A central angle, just like it says, it's an angle whose vertex is on the center of a circle. So, any angle that has its vertex, aka the middle letter, that part where both of the sides meet, and it's on the center, that makes it a central angle. Now, just going over a couple of examples here. We're talking about a chord. That is a type of line segment. So you're going to see that line segment symbol up there, and then the names of the two endpoints. So this is chord AB. Then over here, we got an arc. An arc is going from one point on the circle to another point on the circle, and we call that DE. Please remember, these two are not the same symbols. This has a little curve on it, so that means it's talking about on the circle. This is just a line segment, so that means it's a line segment. Finally, just the same way that we name angles in the past, we can name a central angle, but this time we're going to have to use three letters no matter what. Because if we use less than three letters, that gets less specific, and there could be other angles that share this. Like technically, DCE is this angle that we're coming from right here. If we were going any bigger or any different, we would have to make sure that we use letters to specifically bring us to those ideas. All right, now we talked about an arc earlier as just this portion of the circumference, but there are two types of arcs. We have minor and major. Just like how you think that these might work, a minor arc is smaller and a major arc is bigger. But let's get more specific. So, a minor arc is an arc whose measure is less than 180. When we name these, we're naming them with 2 points. So, why 180? When we talk about a circle in terms of degrees is 360 degrees all the way around. So when we talk about a minor arc, we're talking about a arc that is less than half the size of the circle. Remember, if the whole thing is 360, half of it is 180. So it's us looking for a small arc, something smaller than half the size of the circle. So when we talk about a major arc, it's the opposite. It's more than 180. And this is named with 3 points. Now, why do we name these with three? Why do we name these with two? When we name something with 2 points, it's letting us know this is a smaller portion of the circumference here. Okay? So, a couple of minor arcs we have are AD. I can clearly see this is not more than half the circle, so that's why it's fine for us to name this with two letters. We can eyeball it. Same thing over here with DB, the same thing with BA. Now, when we name a major arc, we use 3 points to name it so that we can indicate not only how big it is, but also which direction we're going. See, if I named this arc from A to B, AB, I don't exactly know if you're talking about this way or if you're talking about that way. So we use a third letter so that we can kind of finesse out which way we're actually going to see how big it is. So see, instead of AD, we would name it a little bit bigger. So this would be going from A through B over to D. So those are the two ways we could name these arcs. We can name this AD. I would know it's just talking about the small one. But if I name it ABD or DBA, then that lets me know I'm talking about a bigger portion of this. Likewise, we also got ADB. If I look around it, if I look around through those three letters, I can tell this is bigger than half the size of the circle. Same thing with BAD. It is bigger than half the size of the circle, so I can make sure I can understand that's a major arc. All right, jumping into some more facts, some more information. We're going to talk about three theorems. So these are properties that are going to come in one after the other based off of the fact that this is inside of a circle or within two congruent circles. So let's talk. Within a circle or in congruent circles, congruent central angles have congruent chords. So if I have a set of central angles, a chord that's made up from two of the sides that we have, not two of the sides, from the two endpoints of our angle, that's going to end up making us a set of congruent chords. Congruent chords are going to have congruent arcs. So if I have a line segment coming from two parts of the circle, and it's congruent with another line segment from two parts of the circle, then the arcs that are made from those connected parts are in fact congruent. All right, last but not least, we got congruent arcs have congruent central angles. So if I have an arc, then that means that the central angle that's made up of the endpoints of that arc is congruent to another central angle that's made up from another congruent arc. So let's give you a quick example to make this, kind of hammer home. All right, below here we have two circles, circle Q over here on the left and circle A over on the right. They're both congruent. Remember, whenever you see this symbol here, this is a blast from the past, we're talking about two objects that are the same. So these two circles, Q and A, they're both the same. Along with this, they give us another set of congruent parts. RS is congruent to BC. So let's go through and make sure we're aware. This whole circle here on Q is congruent to this whole circle here on A. So these two, they're both congruent. Then they give us some more information. They tell me that these two sides here, RS and BC here, these line segments are both the same. So we're going to go through, we're going to highlight that. Actually, let's mark that up instead. Let's go. All right, so one more time, we're going to make sure that we match up real quick the stuff that we know. Now, if this line here, this chord BC and this chord here for RS are the same, congruent chords make congruent arcs. So that means that this arc coming here from R over to S and this arc coming from B over to C, these guys are congruent just the same way that these two line segments are. Now, if I have two sets of congruent arcs, that means I have two congruent central angles. So that means that this angle here at the center with Q and this angle at the center of A are also congruent. So, what can we conclude in general? These arcs, RS and BC, they are also congruent. And these angles, RQS and BAC, are also congruent. Okay, so if it seems easy, it's just because we're getting used to it, you're trusting it, you're not letting it go through and make you panicked. Now, Let's go through and use some of these aspects that we just talked about so we could do a little bit of algebra, a little bit of math, flex our skills here, okay? All right, we have to use the information that we know. So in our first example here, they tell me that if jk is equal to 6x plus 2 and lm is equal to 8x minus 8, they want us to find jk and lm. And that seems like a lot right now, but there's a lot of information they've given us here. See, this degrees, and this degrees here, these are talking about either an arc or an angle whenever we see these symbols here. So when we see this, since there's no angle, that means that we're going to be talking about an arc. So this arc here from J to K is 112. This arc from L to M is also 112. If these two guys are the same, remember what we talked about before, congruent arcs make congruent chords. So, not congruent, arcs make congruent chords, the reverse. So if there's one thing, then the reverse is also true. All right, so if these guys are the same, then that means that this line and this line are also the same. So that means JK is congruent to LM. If they're congruent, that means that their measures are equal. So that means we have what we need to solve. So let's go through and start solving. We got 6x plus 2 is equal to 8x minus 8. I want to get all my constants to one side, all of my variables to the other. So I'm going to take 8x and I'm going to bring that 6x over by subtracting. And I'm going to take that 2 and bring that negative 8 over by adding. That's going to give me 2 x's, and that's equal to 10. I got to get x by itself, so I got to get rid of that 2 by division. When I divide both sides by 2, that gets me x equals 5. Now that we have x equals 5, we got to finally go through and get our actual answer. If these guys are both the same, it doesn't matter which x we plug it in, they're both going to end up being the same. But you always want to make sure you check. So we got 6x, so that's 6 times 5 plus 2. And then over here I got 8x, so that's 8 times 5 minus 8. And if these guys are both equal, then that means they should both give us the same thing. This is 6 times 5, that's 30, which gives us plus 2, so that's giving us 32. If we get 32 over here, we got 8 times 5, that's 40. 40 minus 8 is also 32. So we have 32 for JK and LM. So you're just using a lot of the properties that we have there to make sense of this, so we know what's equal and how we could solve anything. All right, give yourself a chance. We got another one here for the I do it. Pause it and come back to me. Alrighty, folks, hopefully you paused it. Let's go through and talk about this next one. Next one we got this shape here. This trapezoid is inside of this circle, and we have to figure out what x is. So let's look at the sides where x is. X is on just one side here. This side, which is 12x minus 6. Now, I have to look at all the information that's here. 12x minus 6 also has this arc here from this point to this point, which is 85. If I want to figure out how to find x, I got to look for something that's similar to this. Either something has an x or something with an arc of 85. So we got 160 down here. That's not 85. We got 50 here. That's definitely not 85. But we have this 85 degree right here, which comes from this arc. So if these two arcs are both 85, then that means, just like before, we have two chords that are going to be congruent. So this side here, 48, and this side here, 12x minus 6, these are both near congruent chords. So that means these, not congruent chords, congruent arcs. So that means they are congruent chords. Let's set these guys equal to each other. So we got 12x minus 6 is equal to 48. And we're going to solve this for x. So our 6, we got to add over to the other side. That's going to be plus 6, giving us a 54. I got to divide both sides by 12. Remember, even though you're not going to get a whole number every time, that does not mean we stop. Decimals are numbers. So when I do this, I end up getting for my x 4.5. Okay. Easy peasy lemon squeezy, folks. So we got another quick example here. These are just like the ones that we had right after our theorems. Let's get into them. These circles are congruent over here, circle B and circle R. One thing I can notice already, they marked this portion. Sorry about that, that's the alarm. We marked this portion and this portion. So these two guys are both the same. What are these? These are both arcs. If these arcs are the same, remember all the other things that can be the same. They have a set of congruent chords. So what's our congruent chords? This is going from A to C. So that means our chord is also going to have those two as endpoints. This arc is going from Q to S. So that means our chord is also going from Q to S. So those two are the same. We also have two sets of congruent central angles. So if you have a set that goes from two matching letters, those two matching letters are going to go through and open up all the other possibilities for you. All right, last one that we got here on our notes. This gives us two different circles. This one actually has a lot more to it than you think. So far, they only marked this angle here and this angle. But we have to know all of the stuff that we could possibly say from this. So if this angle here and this angle are the same, look at what's making them up. We have these lines here. If these lines are crossing like this, that means that these lines here are making a set of vertical angles. Since we have a set of vertical angles, that means that we got four pairs of angles or four angles that are actually the same. So I got all four of these angles, DCE, BCA, JLK, and MLN. Those are all four of those angles we got highlighted in yellow. Now, these all involve the center of our circle. So let's go through and figure out what else we can go through and see is the same. If these angles are all congruent, that means that the arcs that are made up from their respective endpoints are also congruent. So we got these four areas here that I'm highlighting in blue. These are all the arcs at the end of these angles. They are DE, AB, JK, and MN. After we got this, we also got the chords that are made up underneath each of those. If arc DE is congruent to arc AB, then that means that chord DE is congruent to chord AB, and so on and so forth. All right, folks. I appreciate you coming by for this video today, and I hope you have a good rest of your day. See you later.